Hello, today we will practice on combining and solving polynomials. So let's say that we had f of x is equal to 3x plus 8 and we had g of x is equal to negative x squared minus x plus 3 and we want to find the zeros of f minus g of x. So this right here means that you must subtract g from f, and the parameter right here tells you what you are going to evaluate each polynomial with. So this is just basically saying f of x minus g of x. This is a way of just making it smaller and kind of easier to read, but it's exactly the same thing. So when we evaluate that, we get that f of x is 3x plus 8, and we want to subtract negative x squared minus x plus 3. Now let's combine like terms. So we have 3x right here. We have minus negative x. So 3x minus negative x, that's equal to 4x. Now we have the constant term right here. We have another constant term right here. 8 minus positive 3, that's equal to 5. And then we just have 1, and let's cross out whatever we have done already, and we are left only with negative x squared times negative, and that is equal to positive x squared. Let's rearrange this into decreasing order of the exponents, and this is equal to f minus g of x. And now we want to find the zeros of it. So we want to find the zeros. So we have x squared plus 4x plus 5 is equal to 0. Let's use the quadratic formula. So x is equal to negative b plus or minus the square root of the discriminant, which is b squared minus 4ac, and we divide by 2a. Very well. Now we see that a is equal to 1, b is equal to 4, c is equal to 5. So let's say negative b, so that's negative 4 plus or minus the square root. B squared is 16 minus 4 times 1 times 5. We divide this by 2. And so let's simplify first whatever is inside the square root. 16 minus 20 equals to negative 4. So our discriminant is negative. This means that we have no real zeros. However, we do have imaginary zeros. What does imaginary mean? Imaginary means that it contains an I. I is equal to square root of negative 1. So let's find what our imaginary numbers are. Imaginary zeros, I'm sorry. So we found out that we had negative 4 plus or minus the square root of negative 4 over 2. So that's what we got with the quadratic formula right here. I plugged in the negative 4 as the discriminant right there, and that's what we got. So now, knowing that I is equal to the square root of negative 1, we could actually substitute that right here. So what we do is the following. We have negative 4 plus or minus, and here instead of having that, we can say the square root of negative 1 times the square root of 4. Because as you might know, if you have the square root of a times b, that's the same thing as saying the square root of a times the square root of b, like so. So that's the property we used here. And now by doing that, we can substitute this with the I that we had right here. And we're left with negative 4 plus minus I square root of 4 over 2. And now we can just divide negative 4 by 2, that's negative 2. And then we know that the square root of 4 is 2. So plus, minus, and also remember to divide this by 2. So plus, minus 1, which is 2 divided by 2, times I. So we have two imaginary zeros, and that's negative 2 plus minus I, like so. And that's our solution.